Hi there, welcome to patch day 11, I suppose it is by now, or is it 10? Either way, this one I'm going to do the same kind of recycling as I did in the last tutorial, but this time I'm going to do it with video. So video recycling is going to be based on frame differencing. That's what I'm thinking anyway. So I'm going to make a new object called jit.qt.movie, which we've made about 20 times before. We'll take it out of its original size of and make it 640 by 480 for no really good reason. Okay, we're going to use a metro here to read back the frames, assuming this thing's not any faster, not recorded any greater rate than 33 frames per second. I'll take that 30 as a metro. We'll need a toggle to turn on the metro. We're going to want to read something into this, so we're going to make a message called read blading.mov. So that'll read that famous video of a kid rollerblading, and just to be able to stop this thing from looping, because we're not really interested in looping, we can give it the message loop with a 0, not a 1. And when we do want to trigger, that means we'll need some way of triggering the playback of this thing, which a message time 0 will start it at the start of the video. What else do we want here? I think that's about all we really need. Of course, we can hook up a jit.p window here to see what that video looks like. And if we hit the message there, loop 0, and if we turn on the metronome, we'll see it. Awesome. And every time we click the time 0, it'll start from the start. Okay. So the first thing that we're going to do when we, so this should have no looping. Okay, yes, it stopped, good. So to do the frame differencing, usually the first thing you want to do is to do jit.rgb to luma, gb to luma, just to give it, take out, turn 4 planes into 1, just makes the whole thing a lot more efficient. And the other thing you'll want to do, because we're not interested in matrices that don't change, so we'll put in a jit.change, because this frame rate that it's recorded at is probably not 33 frames per second. And we'll do this little combo deal down here that we've done before, which is trigger the matrix, which is a list, 2 times, and use a new object jit.op, and the argument at op, which is telling it the attribute is what kind of operation we're doing, and the name of the operation is absdiff, which is an absolute difference between this matrix and this matrix. And we're going to get the absolute matrix difference between the new matrix and the old matrix. If you're not sure on that, then I guess it's pretty obvious to me, but you know, since this comes out first, that triggers the output, and then this comes out second, so it stores it in there until again it gets re-triggered on the next frame. Okay, so to turn this absolute difference value into a max value so that we can actually do something with it, we're going to use jit.3m, which, if we look at, just scroll over the outlets here, we'll see that this is the minimum in the value in the matrix, this is the mean value, the average value in the matrix, and this is the minimum. Don't know what this is for. Dump out. Okay. So we're interested, I think, in the mean, so that the sort of average change in the matrix. Of course, we could have made a much smaller matrix than 640, 480, I guess. If all we were interested in was let's have a look at that value there for a second. Integer, I for int. I'm going to make a new object. You can tell we're going to see what this average value looks like. So we hit time 0, and yes, I guess the big changes seem to happen in, I'm going to say 60, but this is a little bit like one of those really good cooking shows. I've actually looked at this already. So if this value is greater than 60, that means that we're assuming that the change between frames is enough that maybe it was a change in shot on the video. So again, as with all of these things where we want to trigger logic, only when it changes, we'll need a change on there. And we'll want to select when that change happens, when it goes high. So new, select 1. And what we're going to do with this select 1 is get the time value out of the qt.movie object when we reach that threshold. And to do that, we're going to use a message. So M for message, get time, all just one word, very abbreviated there, get time. And when we get this get time and stick that into the qt movie object, and that's going to come out here, that value, but it's going to be together with the word time, which that word we're totally not interested in, so we'll strip off the word time by sticking it through root. And what we are interested in is that value, which is time. Actually, before I get too far, we're going to store this again in a col. So let's just put a col down here. Actually, let's build what we're going to build at the end here, which is exactly the same thing as what we have up here. Let's check that and that and that. And let's just duplicate that. So holding down the Option key, I'm not absolutely sure what it is on a PC, but we're going to trigger these different spots in the video. We might want to read this in already. We always get that, unless we put a message vol 0. We always get that. And we can see it in the help for the qt movie object. Oh, we're looping on that thing now. Oh, great. Okay, let me turn down the volume then. I won't need sound from Max for this whole thing. We can see here somewhere, yes, loop points. And so you can set the loop points, which will only, of course, work if the video is looping. But we're going to use a list of the end and start points here to set the loop points in the video, which I will connect already, even though this is a little premature since we don't actually have anything stored in the call. So the start and end points of these loop points is what we're interested in. And we're just going to assume that the start of the loop is when we cross over this threshold, and the end of the loop was wherever we were before we, at the end of the last loop point. So we're just going to assume that this thing we want to use everything we have. Yes, so we've got the time value coming out here. Again, we're going to use a counter. It's just, that's not how you spell count. Counter to store as an index for the call, and we're going to make a pack for the 3 values, which is the index, the start, and the end points for the loop points right there. Alright, so we've got part of this thing. When we get this time value here, we're going to want to bang that counter, and we're also going to want to store the old value again, because that will be what we'll consider to be the end or the start of the loop point. To trigger old values, oops, hello, new object, the integer object, which is just I, is a great way of storing the old value. So if you do this kind of deal here, when it gets this time value, it stores it, and then the next phase around it bangs it out, very much the same as what we did here with this list. And that looks like the old, that should be the old time, which will be our start point, so we can hook that up already. There's our start point, and this bang goes here. I already kind of could have connected that. And this is going to be the old, this is the new point, which is actually the end of the loop. I might do something like minus 25 on here. Why? Because I suppose my thinking is that we're actually interested in the frame before the end, which should be about 25. What's the word for it? Time is measured in frames in this world here, which is actual video frames, which I suppose you'll know 25 frames per second is pretty standard, or 30 frames per second is pretty standard. So we're just basically checking out, looking at the matrix that just preceded the change, which is actually the one where that loop should end. That's my guess. That's my theory. We might want, in case we make some mistakes on this thing, we might make a message called set 0. Maybe these aren't even mistakes, but maybe just so that we can use it more than once. Set 0 on that counter. We could also want to clear at the same time as setting 0 on that counter. We could also want to clear the coal, I guess. All right. The other thing I suppose we could use here is a integer to see how many segments we've actually recorded, and another integer to actually read back those segments from the coal. This looks a lot like that last patch a day. So we haven't stored anything in the coal. We can verify that. There's nothing in there. All right, so if we hit time 0, we should be recording these segments. You can see the thing sort of matches up when it changes shot over there. It is kind of creating a new segment in the coal. The coal looks okay, except for this first one here, which obviously that minus 25 doesn't work for the first segment. Oh well, too bad. And if we turn this side on, assuming we've read that movie in there, we can now just choose any one of these segments. So there's the first segment being looped, the second segment being looped. And you see this is fairly accurate. This is the third one. Well, didn't catch that little frame change there. I mean shot change. There's another shot. And that's an altogether not very useful one. That's kind of good. That's good. All right. So that there was my recycling video style action, and I'll see you in the next patch a day.